Skeletal muscles and tendons act on joints to provide the forces needed to rear the front end up and to launch a horse and rider over a jump. However, tendons and muscles also play a key role upon landing, absorbing the impact forces and the limb vibrations associated with the initial phase of hoof contact with the ground and the stance phase. A typical plot of vertical limb ground reaction force seen in the upper panel for a 450 kg horse shows the initial variation associated with hoof impact and limb vibration as the horse's leg makes contact with the ground. These ground reaction forces are absorbed in part by the hoof and tendons of the leg, but the limb vibrations, which are typically in the order of 30 to 40 Hz, are absorbed through muscle tendon length changes. An efficient system capable of damping such vibrations within 100 milliseconds on hard surfaces and more quickly on soft surfaces. Musculoskeletal injuries are extremely common, especially in this intricate spring system. Models show that each cross bridge can absorb 15 times 10 to the minus 21 joules of energy at about 100 Hz of vibration. At 40 Hz, a single cross bridge is calculated to absorb 12 times 10 to the minus 21 joules per cycle. Thus, for the digital flexor muscles, this means that 1 kilogram of muscle can absorb 2.5 joules per cycle, which is more than enough to cope with limb vibration. Thus, digital flexor muscles can be seen as impact dampers of limb vibration rather more than flexors, and as such, their physical performance and balance, left side versus right side on the horse, becomes paramount if injuries incurred during jumping are to be avoided. In the case of the horse shown in this slide, the AMG recordings taken with a CURO revealed that the horse had a tendency to overuse the left side of the body during the takeoff phase of a jump, and also to land more heavily on the left side during the landing phase. Note that the left signal shows a greater amplitude than the right up to takeoff and upon landing. In fact, the owner often complained that her horse was sore and tender in the left hind limb after jumping. After the CURO recording, the owner was able to change the horse's jumping style by reining the horse into a jump or approaching the jump from a different angle, which resulted in a more even use of the gluteal muscles during the takeoff and landing phases of jumping.